Okay, so here's another example to do with friction. So we've got a block of mass 5 kilograms lying on a rough horizontal ground. The coefficient of friction between the block and the ground is 0.4. A horizontal force P is applied to the block. Find the magnitude of the frictional force acting on the block and the acceleration when P is, and then we've got three different values. So there's three different things that are going to be happening in this case. So we can start by drawing a diagram. So we've got horizontal ground, we've got the block, the mass of 5 kilograms. We've got a force P acting here. Friction will be opposing that motion. We've got a reaction force and we've got the weight. So label all these on. Acceleration, if it's there at all, will be going in the direction we're pulling it in. You can't go opposite to it. Friction's not going to cause it to go backwards. If you think about what that would mean, but basically when you try and pull something, it goes the opposite way. It doesn't really make any sense. And the other thing that I want to just make a quick note of is what the maximum value of friction is. So F max is equal to mu r. So 0.4 times by the reaction force. Well, the reaction force is just going to be balancing out the 5g, so it's just going to be equal to 5g. So the maximum friction is 2g. Okay, so in part A, we're given value for P as being 10 newtons. So if P is 10 newtons, that's actually less than the friction, or the maximum friction. Maximum friction, 2 times G, 2 times 9.8 is 19.6 newtons. 10 newtons isn't enough to overcome the maximum friction. So the magnitude of friction force will just balance out the 10 newtons. So F is 10 newtons, but there won't be any acceleration. So it's just 0 meters per second squared there. Question B, same kind of scenario really, because we're told that P is 19.6. That's now matching the maximum friction. So we've reached the maximum friction, so F is 19.6 newtons. However, it is just balancing, it's just holding, it's just stopping this force from pulling this block. So the acceleration is still 0 meters per second squared. So in part A, we hadn't even reached the maximum friction. Part B, we have reached the maximum friction because the force being applied is 19.6 newtons, and that is equal to the maximum friction. So we're in what we'll call limiting equilibrium. Whereas the first example was just equilibrium. And then part C, you probably guessed that it's going to start moving in this example. So in part C, P is now 30 newtons. The friction can't go as high as that. We've already worked out that the maximum friction is 19.6. And so it's already reached that point. So we're dealing with a situation where P is 30 and the friction is up to its maximum of 19.6. So if we resolve horizontally, we're going to get P take F is equal to the mass times the acceleration. And we're just going to use the values of 30 that were given in the question and the maximum friction of 19.6 equal to 5a. So that's 10.4 is equal to 5a. So in other words, A is 2.08 meters per second squared. And I've not actually mentioned yet, but F was 19.6. I'll make a note of that there as well. And so the particle will be accelerating in this particular example.